I'm Simon Maple, and I'm delighted to be here today to talk to you about leveling up secure development in a post-log4j world. And it must be true because it's on the schedule. I'm not 10:20, 9:20. I'm Simon Maple. Well, you may have noticed we have a few surprises. Simon was very surprised to catch COVID, so he can't be here. So I'm here instead. I'm surprised too. So today I'm going to be talking about the future of Java. And you may be thinking, wait a minute, I study the schedule. The future of Java, that's not now. See, it's very important to put the date on talks about the future of Java. But you may be thinking, I saw the future of Java on the schedule. It's not May 11th, it's May 12th. That's tomorrow. And the speaker still isn't Holly Cummins. The speaker is Mark Little. Another surprise. What happened was the program team had a little bit of a situation, and they thought, what shall we do? And they thought, Mark Little's talk on the future of Java is going to be really, really good. It would make a super keynote. But Mark can't give the talk on Wednesday because he's giving the talk on Thursday. How do we fix this? I know, we can get Holly to steal Mark's content. So I should say, by the way, I have two top life tips. One is never, ever, ever become a conference organizer during the pandemic. And the second is stealing your vice president's content is a really good career move. So I said, oh, I can, yeah, for sure. I'll totally steal Mark's content and represent it. So I went away to the internet to try and copy and paste off the internet, as one does. But as you can see, this is where it's really important to put dates on talks about the future of Java, because this is something that we've been talking about for a really long time. So I nearly, by accident, copied some content from 2012 on the future of Java, which would have been interesting, but maybe not interesting for the right reasons. But I think I got there in the end. So in order to understand the future of Java, you really need to understand the past of Java. So maybe not quite that far back, maybe not all the way back to Charles Babbage and the difference engine, but certainly I think it is useful to look back to what Java was like when I started learning it. In 1999, if you bought Java in a nutshell, it was a small book. It was about that thick. About 10 years later, if you tried to buy Java in a nutshell, it was like the complete works of Shakespeare. It was that thick. You sort of had to get a truck to carry it, because Java just kept expanding and expanding and expanding, which I think was both a strength. Everybody loved it. People wanted more features, but also a weakness because it was that big and half of the stuff in there was terrible. So what kind of things made Java the way it was in 2005? Well, stating the obvious, it was designed to run on premises. It was designed to run on fairly hefty hardware. I worked for IBM, and we had some of our clients who were the large banks, and they would run Java on these huge machines that had like heaps of like 100 gigabytes. And they'd come to us with a support request, and we'd say, okay, so can you send us a heap dump? And they'd say, well, no, because you'd need a truck to carry the hard drives for it, because they just had these absolutely massive systems. If you had a JVM, it was probably running on a dedicated server. You had that one physical machine in the data center, and all it had to do was run Java. So you didn't really care how much room it took, but you did care a lot how fast it was. And these processes could be really long-lived. You might start your application server, and then some months later, maybe think about restarting it. So that's pretty different to how things are now. And of course, the thing that changed, you may have heard of it, was the cloud. And the cloud really changed what we needed from our systems. And a couple of other changes came along as well. At around the same time, containers have been around forever, but Docker massively popularized containers. And so in 2013, they really changed how we developed software. And all of a sudden, instead of having something on a physical machine, it was really easy to put it in a small little container, pass it around, share it with our friends. And instead of just having one of these things, because it was kind of hard to manage, it was easy to manage. So we could have 500 of the things. The combination of cloud, which made it really easy to deploy things ideally on someone else's hardware, and containers, which made it really easy to deploy things on, well, pretty much anywhere, created the ideal conditions for the microservices design pattern. But I think for Java, what was most interesting about those changes wasn't really microservices. That changed how we worked, but it didn't really change what we needed from Java. What changed what we needed from Java was more those containers. Because when you had something in a container, if you wanted to change it, you didn't SSH into the container and then try and do a patch and try and do a thing and change the config. I mean, well, maybe you did, but ideally, you didn't do that, because ideally these containers are immutable. You have your configuration as code, and then you really do everything you can to make sure your team don't touch it once it's deployed. If you want to update it, what you do is you throw it away, you make a new one that's as you want it to be, and then you keep going. So we had these disposable servers. And when I say disposable, I'm not sure that quite captures what we're talking about, because it's not like I have my server and I go, yeah, I don't like that server much. I throw it out, and then I carry on and go get ice cream and go to the beach, and my website's down, right? I dispose of it, but then I recreate it again. So it's sort of this model where, you know, it gets disposed, and then it gets undisposed, and then it gets disposed. So I think the model maybe isn't actually a trash can. I think maybe a better model is a light switch. I want to make a change, so I turn it off, and I turn it on again. If it gets corrupted, I turn it off and on again. And so in order to have that kind of behavior of being able to be turned on and off again, it's got to be fast. It's got to start up quickly. And as well, it's got to actually work. I remember when we had big data centers, if we had a power outage, that was a major event, because we knew that if we turned these things off, they might need a lot of work to come back up. But if you're going to be doing this all the time, it's got to be reliable when it comes up, and it's got to behave the same way every time it comes up. So what we're really thinking about here is idempotency. And it has to be said that, you know, people have been predicting the death of Java for almost as long as Java's been around. But actually, if you look at the numbers, Java is still, this is the red monk figures, and Java's, you know, maybe not quite at the top, but it's still pretty near the top of the popularity rankings. You know, it is, if you want to be employable, Java is a great thing to do. But when you look at some of the cloudier things, it's maybe a bit less true. So I should say as well, I joked about stealing Mark's talk. This is actually quite different from Mark's talk, so you definitely should go to Mark's talk as well. But I did steal one slide from Mark, which is this one. So again, great career move. If you look at serverless adoption, Java has only 6% of the serverless market, and almost everything else is written in Node.js and then a little bit of Python in there. So why is Java, this language that we all love, that we all think is great, why is it so awful at serverless? It's back to that light switch model. Java servers are really not at all like light switches. I mean, this is true for a number of reasons. One is that one is like a thing that is on the wall, and you know, you push it and it makes light, and a Java server is a thing that makes cat pictures on the internet. But it's more than that. The characteristics of Java historically have been that it's kind of slow and kind of heavy to start. But I think all that's changed, actually. And so I want to go back a little bit. I mentioned that I learned Java in 1999. I want to go back a little bit and talk about what I did since I learned Java. In 1999, I got Java in a nutshell. I taught myself Java. And some years later, in 2017, I had the honor of being nominated as a Java champion. And it was actually a little bit awkward. I didn't tell the Java champions this at the time. But in 2017, I wasn't really working on Java anymore. I had been a WebSphere application server developer. I'd switched, and I was now a consultant in the IBM garage. And since 2015, what I'd mostly been doing with my time was writing JavaScript, writing Node.js. And I had been one of those developers who always used to joke about the JavaScript ecosystem and the terrible type characteristics and all of those things. But then when I actually tried it out, I kind of really liked it. There was a lot to love about Node.js. So what's happened since then? Why, since 2017, when I was kind of like, don't tell them, and now am I talking about the future of Java? Well, I think it's partly I've changed, but it's also that Java's really changed. So what I do now, as of about a month ago, is I work for Red Hat, and I'm a software engineer helping to build Quarkus, which is really cool. And what made me sort of move back to actually helping to build the Java ecosystem was that I saw a lot of the things I really liked about JavaScript. Like, it was so fast to start, and it had this, really dynamic behavior, and it was functional, and it was so expressive. I could do things just in a really short time, and so it made my life as a developer pretty happy. A lot of those we see now in Java, with the possible exception of being functional, actually. I think Java's functional support is limited, but we won't talk about that. Because really, it's good to be back. I've had sort of, my little affair with Node.js, but I'm back with Java. And as I said, while I was away, Java really changed. And I think one of the things that's really driven this change is the modernization of the release schedule. So Java is improving in a much more iterative, easy-to-consume, delightful way than it used to before. So every time a new Java release comes out, there's these sort of presents. So with the most recent releases, for example, we have the var keyword so that we don't need to declare all the types. That's really cool. And also, the actually useful null pointer exceptions, which is so obvious when you think about it. Because how many times have we spent trying to put in the system out print lines to figure out which of the 6 arguments on the line that has the null pointer exception was actually null? It's really annoying, it's really stupid. That is now fixed. So I'm desperately waiting for my first null pointer exception so that I can actually see it working. Because, these things, technically they're called features rather than presents, but they feel like presents. And of course, the big thing that we're seeing is that Java has very much shifted to the cloud. I think it's a journey to become cloudy. I think Java's not completely 100% there, but it's definitely been on that journey, and it's pretty much on the top rung. And for example, to put some sort of numbers behind this claim that Java is now completely cloudy, if you look at a modern framework for a REST app, it will have a 13 megabyte footprint, and it will have a 0.014 second start time. So I was sort of, when I was preparing these slides, I was looking at that number, and I had to I'm still not 100% sure I've got it right, because math is hard, but I think that's 140 milliseconds. But I wouldn't swear to it, because it could be 14 milliseconds or it could be 1400 milliseconds, because math is hard. But basically, it is ridiculously small. It's small enough that I can't, when I'm tired, look at the number and tell you what it is, because it's so small. So that's with Quarkus running on GraalVM. You see not quite as ridiculous, but still really good numbers with Quarkus running on just normal OpenJDK. You see really good numbers for other frameworks as well. So, this is something that we're seeing as a trend to this really ridiculously implausible footprint. And I think one of the things about this that's really nice is these improvements, they were done, I think, with the intention of increasing density in the cloud. So if you, instead of having a dedicated machine, you have all of these tiny little containers packed in, all of a sudden the resources it consumes matter. And if you're taking it down and up again and down and up again and down and up again, the startup time really matters. But those requirements that were driven for the cloud environment actually make our life as developers totally better too, right? Because now instead of having to start the application server and then sort of go off and get a cup of tea, it's just there. So I think it's a little bit like what Julien was talking about, where making changes to improve accessibility, and you have in mind that 15% who have, sort of an issue, and then all of a sudden you discover that you've made life better for a whole other group of people as well. So, for example, the second language learners and that kind of thing. And it's a bit the same here, that if you target the cloud, then the developer experience usually gets way better as well. And we had the opposite when I was working on Open Liberty. Our starting point was, we started it before the cloud was really a thing, and we said, how can we make WebSphere great for developers? And then we realized that actually by making it great for developers, it had become great for the cloud as well. So we get these sort of synergies between the requirements. And I think what the journey that we're on now is going past just making it good for the cloud to make it what we call Kubernetes native. So what I think this means, it's sort of a woolly term, but one of the really important things here is those performance requirements, that footprint, that startup, so it can operate with high density. But also in terms of the operations experience, you can't be having to manually drive things with scripts. It's got to be declarative in its configuration. And then I've sort of put it last on the list, but in a way it's the most important one as well, is that developer experience that we're just not going to put up with a terrible developer experience anymore. It's got to be frictionless. And the way we get these, I think sometimes when we talk about Java, it's easy to focus, or tempting to focus just on the JVM and the JDK. That's the core, that's where the language features are. But the Java ecosystem is actually much bigger than that, because the other thing that's really important is, how do we get these things? How do we consume them? So we need to have those easy-to-consume binary distributions. And this is something that London can take a lot of credit for with the London Java community and Adopt OpenJDK, that then went on to become Eclipse Adoption. And then the final piece, of course, is we're probably not going to be coding straight to the JVM if we're doing something like a web app. So we need to have those frameworks on top of it. And that's where they, in the worst case, can take something that was kind of small and make it huge and massive and monstrous and slow to start. But in the best case, they can actually make it smaller by peeling out of what we deploy everything that we don't need. And of course, they're really important for the developer experience. So one of the things that, Java's always been great at having that cross-release compatibility, unlike some other languages. That, it's got that stability, which is why it's so suitable for the enterprise. Since maybe 1.2, it has been really performant. And one of the things that I think is so great about Java is how much cross-vendor cooperation there is. So that's all stuff that's sort of historic Java and is still continuing. But now we're seeing these new things. So we're seeing this rapid iteration. We're seeing this move to cloud native. We're seeing, the more than that, the Kubernetes native. And then combined together, then we get, not just that those three pieces, but our frameworks are making it really easy to develop, and they're getting easier. And our binary distributions are getting easier as well. So I think it's a really good time to be working with Java, and I think it's going to get better from here on in as well. We're on such a good trajectory with Java. So with that, thank you. And I think we have a recording of the real Simon Maple as well. So thank you.